Well, anyway, so I like Pandas because it's it's from the Python. Yeah, exactly. Yeah, real Python. Yes. Yeah, they have very nice tutorials and articles. Yes. So again, import NumPy, import Pandas. Wait, something. Okay. So what I want to say is first that NumPy also has structured arrays, which work a bit like dictionaries, and then Pandas has something like lots of stuff, and then we can see also like how to import data. I think one thing that you asked before about importing data with NumPy, I didn't cover it here, but the command is basically np.loadText, but we will see it with Pandas. It's roughly the same. Okay, so I told you before that NumPy only accepts the same type, right? Everything has to be array, a string or float or integer. But if you want to have mixed things, you can do a structure. So you can say, okay, I have name of people, their ages are integers, and their weight are floats. Now you can create, it's basically a structure in NumPy. You can start it with zeros, so 4 zeros, because you have 4 people. And you can say that there will be certain categories with these names, name, age, weight, and certain formats with this like string, integer, float. So it creates data. And you see that dtype now, instead of giving just one thing, gives you 3 things like string, integer, float. And you can access this like that. So basically it works like a dictionary. So these are the keys. And you can tell, okay, data name is equal to name. Name was a list of names, list of integers, strings. Age was a list of ints, and weight was a list of floats. And if you print it, you see you have tuples. So basically what NumPy is saving is 4 tuples with these formats. So what you have done in the previous step is to specify the formatting of each of these elements of that string. So quickly, because I think this is very useful and very interesting, but I think you will in practice, if you have to do this, then it's better to use Pandas. So, but I just want to say it's possible with NumPy, but if you really have to do this thing, then use Pandas. So you can access the first row like this. You can access the last row, and in the last row access the name, or for example, the age, okay? And you can also mask. And this is where you're combining now NumPy dictionaries and stuff. So I'm saying data gives me from data everything where data age is smaller than 30. So you're combining the power of NumPy by saying, okay, give me all whose age is smaller than 30 and give me the name of those people. So you get Alice and Doug very quickly. If you print data again, it's this, right? You can also see who is older than 30. Okay. And that's it. I mean, I'm sure there is a lot of stuff you can do with this, but for a scientific application, I would say go to Pandas, because once this gets to starting more complicated, then this is not so useful. And also, Pandas has a very nice representation. When you print a Pandas object, it doesn't print this ugly thing. It prints a nice table. So that's why Pandas is much nicer. So let's start with series. Series is one-dimensional arrays in Pandas. So you give to Pandas an array, and you say pandas.series, and it gives you data. Notice that this is now a combination of two things. An array. This is basically can be converted to a NumPy array, and this is an index. And it tells you what kind of things you have in this series floats. Okay, so you can do data.values, and you get the values as a NumPy array. You can do data.index, and data.index is a special object. In this case, it's called range index. So it tells you when it starts, when it stops, and the step. It's basically like the arrange function. And then you can access, this is the nice thing, you can access data in the same way as an NumPy array. So remember data, if you do 1, 3, it slices. Okay, nothing special so far. And now you have an explicitly defined index associated with the values. So if you, for example, don't want these indices to be integers, but you can have, if you want to have, for example, strings, you can do it. This is the nice thing of Pandas. So basically, this is the thing of Pandas. So you have the array, and you say instead of 0, 1, 2, 3, give me A, B, C, D. Okay. So now this is this, the same array as before, but the index is changed. And now it works like a dictionary. Exactly. Now you can do this. Okay. So it's a specialized dictionary. And the good thing about that is that you can pass dictionaries to Pandas automatically, and it creates the series. So you can say population, California, Texas, New York, Florida, Illinois, and you have the population. You give the dictionary to Pandas, and Pandas automatically understands, okay, this is the index, and this is the values. And so you can access it like a dictionary. What is the population of California? But you can also very nicely slice in names. Okay, so you can do, give me everything between California and New York.
Which ordering you ordering to get from a value to another value? It's ordering of the index.
It's the ordering of the index. If this is what you mean, like, or you mean the sorting of this, or
yes, from the position named California to the position named New York.
Ah, yes, yes, it's in this ordering. The index is ordered. Yeah. Now they are ordered in after 3.
Yes, in the order. You could have another order,
No.
like alphabetical. From the you could use another order like the alphabetical order from the A to the Z.
No, look, I think dictionaries are now ordered in Python by default. Look, yes. But wait, I'm not sure in the printing. I think it depends. I'm not sure. I had heard that they were ordered now because.
Now they're ordered.
But this is not ordered. This is not. But not here. Like in this case, for example, it's not ordered in the key, right?
You make a slide from California to New York.
It's ordered according to the order that you passed.
Exactly. It preserves that one.
Yeah, but it contains the order.
Yeah, exactly. It's not alphabetically. Yeah.
Okay.
Yeah, exactly.
It's the insertion order.
Insertion order. Exactly. Before it was not. They were just saying it doesn't guarantee what you like. Yes. What you get, it was not guaranteed. Yeah.
By design, dictionary has no order. Just came up.
Right, but now it's insertion order. Yeah. Anyway, so the slicing is sorry.
Je le fais en français rapide. En fait, il dit je je veux les valeurs de telle valeur à telle valeur. La question c'est savoir, oui, d'accord, mais les valeurs intermédiaires, dans quelle ordre il est pour. Donc on se rend compte qu'il faut aller dans l'ordre d'insertion, il va faire un ordre alphabétique.
Tu cherches l'index. Par exemple, tu cherches l'index correspondant.
C'est ça, voilà.
Yeah, exactly. In the slicing, it will, in this slicing here, it will preserve the thing, like the index. Like if you do population dot index, this is the order. So if you do California semicolon New York, it will give you California, Texas, New York, right?
So if you make a slice from New York to California, you will have nothing.
Good question. I have never tried that. No, zero. Yeah.
Yeah, actually there is a hidden index.
Yeah, there's a hidden
from 0 to
Yeah.
and I think afterwards you will show that with the IO.
Yes.
So there is always a hidden index.
Mm-hmm. Yeah. So exactly, you have to be careful because sometimes if the series has as keys numbers but as values strings, you can get confused, right? You can think series 2 is the second element, so 0, 1, 2, right? But it's not. It's series corresponding to 2 is the key first, right? It's like a dictionary, so it behaves like a dictionary. But then also here, for example, like I'm slicing from 1 to 6, but I'm not really slicing in index, right? I'm slicing in keys. Okay, so I'm getting B, C, D. So whatever these values of the index are, I'm slicing in them. Okay. And now data frames is the useful thing. So now imagine you have now the area of those states. You create a series of the area, fine. But of course, what the first thing you can think is, okay, now basically I can join this data. So I have this data and the other data, but it's for the same state. So I should join them together. So you just say, in the same way that we did before with the NumPy structure array, you just say, okay, I will have two things. One is called population, the other is called area. This will be a series, pd.series, and this will be another pd.series. So you can construct a data frame from a dictionary of keys and series. So this is a column, this is another column, and this is the column name. So, and now if you print it, it looks like this. Okay. So and this is everything. I mean, this is basically the main idea, and the reason to use Pandas is now that you can do lots of stuff here. I mean, you can act on it. So first of all, data frame has an index attribute. In this case, the rows still the same, but now the columns, they have an index. So there is a hidden index in the columns because you will see later, you can also slice in columns. So the data frame knows the ordering of the columns, and it matters, right? So if you actually act on states with a key, it will give you the column. Okay, so remember, this is a table now, and the area column is this one now. Remember, it's not the same as for series. In series, square bracket access the index, so access the rows, right? So in this is a bit confusing. In data frame, this key access the columns. Okay, this again, and now there is a special method called lock, which accesses now the rows. So basically, you can say lock California, and you can slice in lock. Okay. So what you cannot do is to try to get the 0th column or the 0th row. It will give you an error, right? In order to do that, you need to use lock, or we will go to that in a second. So okay, so right now what you can do is, if you want to access the rows with lock, if you want to access the columns, just like this, just like a dictionary. Okay, you can do again list of dictionaries. You can pass it directly to a data frame and it will work. Okay, and the nice thing, if you're working with data and incomplete data, I mean, this is very useful for people working with, I don't know, marketing or whatever. So if you have people called ABC, but you have other people called ADB, you see that there is, in this dictionary, there is no D, and in this dictionary, there is no C. So what data frame, instead of complaining, I mean, instead of complaining, data frame will, I don't know if you can see, but it's a bit weird, the printing. But the data frame will not complain. It would just add nonce here, where it doesn't match, right? So it knows there are two rows. That later you can name them even, and it will just put nonce. And they're actually in Pandas. I'm not putting this here, but there are special functions, methods, where you can drop the nonce and drop the arrays that, like the columns that have none, or I mean, there are lots of things you can do. So the point is that it doesn't complain when you join incomplete data together. Okay, so if you want to name again the things, you can do it. Okay, so you can say, for example, data frame. It's a, instead of passing dictionaries, you can say, okay, I want a matrix 3 times 2. My columns are called X and Y. My indices are called ABC. Okay, and you get this. So is this clear? There are two ways. One, passing dictionaries, or you pass a NumPy array and you pass the columns and the indices separately. The nice thing about Pandas is that you can name the columns and then later you can rename them, you can swap them. For example, if you want to swap X and Y, there is a method where you just do pandas.reindex, and then you give him the columns YX. So you pass the array YX and it automatically swaps the columns. So it's very, very flexible, but same thing here. I mean, you just, for example, remember in dictionaries we saw with Sam, to add like a new entry on the dictionary, you just do it, right? Same here. I want to add a new column. You just do this. You just do XY data set equal series, and that's it. It's even easier than that. You can even do this, for example. You can do XY data W equal 1, and you add like a new column. And you can add as many columns as you want, right? Okay. All right. So I think this is not too important. I mean, this is just the same thing before. I mean, you have XY data, you can transpose. What is the second column? Yeah. Okay. Fine. I think it's C, because now the third column, because now the rows A, B, C are columns, so the third column would be C. Okay. All right. So now a couple of things on manipulation. So you have the states. Again, as I said before, this is very practical if you're manipulating data. So myself, I use it, for example, if I'm working with in cosmology, so I have, I don't know, density of the universe, or if I have omega, like fractionary density, so I have 2 columns, and I can always divide density divided by matter density, so I get the fractionary omega by just doing this, right? So I have population divided by states is the density, and automatically I get like a new column called density. So this is using the U funcs internally. So this is acting on the whole data frame as a NumPy array with this. Again, no loops, no these comprehensions, nothing. And the same thing that we saw for NumPy works here. So give me all the states whose density is bigger than 100. I would not expect Florida actually to be there, but because it, I thought it was like not so much populated. But anyway, um, this works.
Because the states infinity greater than 100, it's narrowing of Boolean.
Yes, I think so. It's a PD series of booleans. Yeah. Basically, internally, this I think they just define this with the dunders. Look at the numpy array, do that, and then turn it back. I mean, there must be something like this internally. And then, but then since we have to keep this ordering, you get that, right? Okay, and now indexing with lock and iLock. So again, let's go back to a simpler thing. So again, to avoid confusion, data2 is, so let's go 1 second. Data is this, okay? So this is what we call an, so look at the indices. They are 1, 2, 5, 6. They're not contiguous, right? They could be 1, 1 million, whatever. So if you do data2, it gives you the, not the third, but the one that corresponds to 2, right? So this is, it's called explicit index because it's really corresponding to index 2, okay? If you do data3, what happens? Error, right? Because, and this is very important in your code to test because there's a lot of confusion, right? Like you can say, give me the third, whatever, fourth, but it doesn't exist, right? It's 1, 2, 5, 6, so it will complain, right? It's like accessing a dictionary with a key that doesn't exist. So I think this is already clear. This slicing works fine. I mean, I think this puzzle is too easy for you. Okay, so however, the surprising result is explicit indices when indexing while implicit indices when slicing. So I think this is the confusing thing, and therefore I think we should like always use lock and lock. So again, what lock? If you look at data is 1, 2, 5, 6. So data lock use explicit index. So if I do data lock 2 is B. But if I do data lock 1, 3 is actually a slicing here, right? Okay. And notice that now these things are included, 1 and 5, because it's not anymore like in Python, in normal NumPy, where the slicing goes from 0 to whatever index you have in the array. Here is in these things. So it really goes from 1 to 5, okay? If you do this, it will complain. Sorry, not complain, give you another thing because this is implicit indices. So this is actually going from 1, so 0, 1, 2, 3 until 5, whatever it can get, right? So look at so therefore you should always use lock because lock is clear, right? Lock is the indices that you have here in your data frame. So if you index with California, Texas, it works, and if you index in the columns, it works. Okay. And iLook is what you said there in the back. iLook is this hidden index that you have. So remember, data.index is this 1, 2, 5, 6. So 1 is going to give me the second entry because this is now 0. So, okay. Is the confusion clear?
Just a memory thing. So location is for the L is for label.
The lock?
Yes, I'm reading the official
okay.
documentation because I always confused between the two. So log is for location access, and elog is for index location access.
Exactly. So this one is accessing the index.
Yes.
So not real,
log,
not the hidden one. So not 1, 2, 5, 6, but 0, 1, 2, 3. That's why if I give him 1, gives me B, right? It doesn't give me A. But if you do lock,
log is for label. So
is A.
The right.
Exactly.
The left column.
Exactly. So I think sometimes, depending what you want to program, it's better to have I lock, because with I lock you are sure that you're accessing. You might not know what this is, but I think it's also, I mean, you can also always loop over the indices, right? Like this is an index object which is how do you call this thing? Iterable, right? Iterable, this object. So you can, it's like range, so you can iterate over iterable. So this is an iterable object, so you can always say for E in data.index and then whatever, I don't care. Okay, so this is this and this is that, so perfect. All right, so again, from the Zen of Python, explicit is better than implicit. So it's better always to use lock and iLock, you know, instead of like depending on people knowing if this is an array, a series, or a data frame or something. Okay. Some more examples, columns, and so on. So again, this is again the confusion. I mean, you can go through it a bit in general. Okay, so lock. Okay, so last couple of things is basically that you can basically operate between data frames and series in the same way that you do it with the NumPy. So look here. You can do sine of data frame times pi divided by 4. Okay, so you can act on the whole data frame. So this is ufunction broadcasting in one step. And this is a thing that you have to be careful. In NumPy arrays, the operations work row-wise. Okay, so if you have a NumPy array and you do a minus a0, this is accessing the row, right? So this is telling me do this matrix minus the first row, right? So that's why the first row is 0, right? Because I'm from this array A, I'm removing the first row, so the first row is 0 because it's the same. Okay, but in Pandas is different, slightly different. You create a data frame. By the way, look at this trick. For example, you can pass the columns like this, list ABCD. So it's a list of strings ABCD. So you have this data frame, and now if you want to act on this data frame, if you want to subtract the column, it's very easy. Because you can say data frame minus data frame iLock 0. You get this, right? So, sorry, no, this is the first, subtract the first, yeah, subtract the 0 row, I think. Yeah, let me check one thing. Yeah, I think it's this row. Yeah, sorry, here is this row. Okay, and you can also do it with lock. Okay, so you can also do from the data frame, remove all the one, sorry. Yeah. Okay. But if you want to do column wise, you have to do it like this, a bit more complicated. Okay. Yeah. Sorry for the typo in the thing. So if you want to subtract the column, you have to do the F subtract, and then you have to tell him the column and say that it's along this axis. It's a bit complicated. Again, not very practical, but you will probably look at it later. Okay, so let's go to importing and a couple of examples. So you can import data frame. So this is temperatures in this country. Costa Rica is like the temperature is very stable all the time. So you can see that with head. So if you do CR temp, you get all the, for every year since 1958 until 2019, I think, or 18, you get all the temperatures. But since it's too much, head shows you the 5 first rows, and you see that the average per month is like 20, 21, 24. It's always the same every year, every time. So there is no winter, and also no hot summer. It's very nice. If you now like looked at, like if you actually import just the CSV file, you will get an annoying index here that you don't want, because you already have N or you have the year. So you can actually tell to Pandas, okay, import the CSV and take as an index the column 1. So now basically the index is the year and the index is named, okay? So if you do crtemp.index, you will see that the index is all the years and it has a name, okay? So the index column can also have names. It's very, very useful. Okay, you can get the columns, you can get the temperature, and so on and so forth. So, I mean, there are lots of things to do. I think I like the first exercise, basically, I think is very important because it basically is a guided exercise. But what time is it? Yeah. But let's just talk through it, and you can do it at home. But I think it's important because like right now you just saw like, okay, how to import, how to deal with columns and stuff. But if you really want to work, you really need to start doing things. For example, okay, if you take the states, right, that we had before, imagine that this data frame was from the year 2010, okay? So add a column to the states data frame that specifies the year of the data. This is very easy, right? So you just do states year equal 2010, and then automatically you will have a column, okay? And then imagine that the population increased 10% in all states except Florida, where it decreased. So now you can imagine what you can do. For example, you can slice, multiply that slice by 1.10, and automatically you will be modifying the data frame. And then you can add another column called 2020, okay? And you name this new data frame states 20, sorry for that. Okay, and now, however, you have to update the density, but this is very easy. You just do states density equal population divided by area, okay? Now, there is a function called reset index. So what you will have now, I'm just guiding you to the exercise, but try to do it at home. So you will have two data frames, one of year 2010 and one of year 2020. And they will not be compatible because Pandas will complain that you're repeating like the index with different like values of the columns. So if you want to add them, you have to reset the index so that you have explicitly the indices from 0 to 5. And then you use append. Use the append function, ignore the index, join the states. And now it starts getting interesting because now you can say, for example, first of all, rename my column to state. You can start placing like, the important thing here is this multi-index thing. I will leave it for the exercise. So use this function. And what this will do is it will show you the table instead of with one index, with two indices. So there will be an index for the state, an index for the year. So you will have like California, and then you will have two different years, okay? So roughly, I mean, this is useful because then you can do things like group by, you can apply mean, you can do max, you can do statistical functions, deviations, I mean, all this kind of stuff. So Go through the exercise. I mean, it's basically very guided, so you just have to use the function specified here. The only thing you have to check is if you do pd.dat or data frame.dat. I mean, it's basically one of those cases. And then you can obtain, for example, means. So you can do the mean of that state in all the years, or the mean of that year in all the states. So you can start playing around. Like, it's very useful for playing with data. And yeah, and finally, one complicated thing. There is a no, I cannot show it actually. Here, remember the slice object that I showed before, slice parentheses. In Pandas, it's called pd.indexSlice. So you define this idx, and then you can actually create this object before and applying it later. So you can actually create indices that you can store, slices, sorry, that you can store. You have to use pd.indexSlice because there is a small complication, because once you have multi-index, if you have here, when you set index to 2 indices, it gets complicated to do it like without this, because you have to specify all the levels all the time. So indexSlice actually helps you to have like a more NumPy kind of thing. And remember to use log. So yeah, that's basically this exercise. And then the other one is keep playing with the CSV file. So there's a couple of exercises here. I mean, which is the hottest month, plot these things. I mean, a nice thing of Pandas is that you can always do, let me do it actually here. You can always do, for example, this, right? So actually, the columns of a data frame are attributes of the object, okay? Of this instance of this object. So basically, you can do this or you can do that, right? It's the same. So you can actually do this dot plot. Sorry, I forgot the matplotlib. Things like this, right? Did I?
Just 1%.
Yeah, just 1%. Yeah, yeah. So actually, Pandas allows you to plot super quickly something, right? So automatically, when you do this, is a table of temperatures. You access a column, you say plot that, and since you already dealt with the index, you already told Pandas that this is a year, it will automatically plot data versus index. Okay, so it's very useful to check if, for example, which are the months, right? So if you want to know, for example, here, which are the columns, you do this, right? And you could do, for example, for a month, well, I mean, there's an annoying column there. For month in this plot, okay? I think I think this works. Let me see. Yeah, this works. There's this end that is annoying there, but like just for the sake of the to go to the next node. So you got the idea, right? So basically you can plot the temperature and you see that it's very constant, right? In all the months, all the years, okay? So play a bit with these exercises and that's it. I don't know if there are any more questions. Yes? Yes, you have fits. You have I think HDF5, and I don't know which other binary. Like I'm not sure. You should check. I never work with these kind of things, but I'm very sure. I mean, there are many things. I mean, there is the ones usually use is, for example, pickle, which is a Python thing. There is JSON. I mean, this is not binary, right? It's not binary, but there's fits, HDF5. These are the most commonly used in astronomy. I don't know, Ud. Yeah, but I'm sure that in the documentation you can find lots of stuff.